Hello, everyone. Thank you for joining and welcome to AI 101, the first webinar in our AI Education Series from Aseto AI. My name is Michelle, and I'm an AI Education and Communication Lead here at Aseto. It's great to have you with us today. So first, who are we? Well, Aseto is a custom AI solution provider. We specialize in voice AI agents and omni-channel solutions for businesses, healthcare, and public sector institutions across the EU and particularly in the Greek AI space. We believe in transparency around AI technologies, and we're aiming to enable both our clients and the public to better understand the AI market, especially AI agents and the solutions available. So this is the first video in our series, and we have a lot of fantastic ground to cover. My goal is to make the complex topic of AI as clear, accessible, and most importantly, relevant to your work. So we'll start by looking at how AI is already a part of your daily life. From there, we'll take a quick journey through the three major eras of AI to understand how we got there. Then we'll decode some of that jargon you've probably been hearing, like AI, ML, deep learning, LLMs, and I'll give you a simple way to remember how they all relate to each other. After that, we'll get into the single most important concept of the day, the fundamental difference in how AI thinks. Finally, we'll put it all together to understand the technology that's making all of the headlines, generative AI. All right, let's get started. So, why are we talking about AI now? Well, let's start with a question, and you can just think about it for a moment. But have you noticed that in the last year or two, the term AI just seems to be everywhere? It's in the news, it's in our software updates, and it's even in conversations with friends or colleagues. For years, AI was an academic concept, something you'd see in maybe movies, but mostly in research labs. But in the last couple of years, it's exploded into the public eye, and now something has fundamentally changed. We've hit a critical inflection point, driven by the convergence of three powerful forces: access to massive amounts of data, incredibly powerful and affordable computing, and decades of research into advanced algorithms. This convergence has brought AI out of the lab and placed it directly into our workday. And that's why we're here today. This flood of new technology can feel overwhelming. So our goal isn't just to give you a list of definitions. It's to give you a mental framework, a way to understand how this technology actually works, so you can think critically about it and start seeing the real opportunities for your workflow, your team, and your industry. So to prove that AI isn't some far away sci-fi concept, let's first appreciate where it already is. It's not a future of robots taking over. Instead, it's an unseen layer of intelligence in tools you're using every day. In fact, let's just take a quick look at your morning so far. Did you unlock your phone with your face? That's AI computer vision at work, recognizing a unique pattern, your face, to unlock your device. On your commute, did you use a navigation app to reroute you, maybe due to a traffic jam? That's AI making a real-time prediction using data from thousands of other drivers. Did you check your email today? Your spam folder is actually powered by AI using classification to identify different patterns in emails to determine whether an email is junk or legitimate. And finally, maybe you've already started writing a message to someone. Modern text editors do more than just check spelling. They use natural language processing to analyze sentence structure and tone, helping you refine your message. So as you can see, AI is already this invisible layer, constantly working in the background, handling prediction, classification, and pattern recognition. But these different capabilities didn't just appear all at once. They represent an evolution. And to understand the powerful generative tools making headlines today, we can't just start here. We need to see how we arrived to this point through three distinct eras of capability. So, how did we get from a simple spam filter to an AI that can write an email for you? It didn't just happen overnight. The best way to understand this is to think about these three major shifts in what AI can actually do. Era 1 is made up of rule-based systems. Now, the mantra here is simply, if this, then that. This is the foundation for traditional computing, where a human expert has explicitly programmed every single rule. Think of like a tax preparation software or a building's climate control system. It's powerful for defined purposes, but it's completely brittle. It can't handle anything it wasn't explicitly programmed for. The next big leap was Era 2, pattern recognition, which is powered by machine learning. The mantra here is learn from data. Instead of programming rules, we feed the machine massive amounts of data and let it learn the patterns for itself. This is the engine behind things like Netflix recommendations or credit card fraud detection or even sales forecasting. It's not following a rule. It's making a statistical guess based on historical data. This is where most business AI has been focused for the last decade. And that brings us to today, the third and most disruptive era, content generation or generative AI. The mantra here is create something new. These systems don't just recognize patterns. They use their understanding of those patterns to generate entirely new text, images, code, or even data. This moves AI from being a purely analytical tool to being a creative and collaborative partner. Now, that second era, pattern recognition, and the technology that powers the third era, content generation, are where the terminology you hear every day really comes from. So let's quickly define these terms and see how they relate to each other. The easiest way to understand the relationship between these terms is to think of a set of nesting dolls. The largest doll, the entire container, is artificial intelligence, AI. This is the broadest term for the whole scientific field of making machines capable of tasks that normally require human intelligence. Inside that doll is the next one, machine learning. This is the most powerful and common type of AI. ML is focused on the idea that we give a machine lots and lots of data and let it learn the patterns for itself. This was the engine that powered Era 2, pattern recognition. Finally, inside the ML doll is the smallest and most powerful one, deep learning. This is a highly advanced type of machine learning that uses complex structures called neural networks. Deep learning is the powerful engine that unlocked Era 3, content generation. So if deep learning is the powerful engine at the center, what does it build? It enables incredible applications, and the most famous one right now is the large language model, or LLM. An LLM is a specific type of deep learning. It's an AI that has been trained on a massive amount of text, which allows it to understand and generate human-like language. When you hear about tools like ChatGPT, you're hearing about an application built on a large language model. So earlier we went through three major shifts, from rules to patterns to creation. And now we have the key vocabulary: AI, ML, deep learning, and LLMs. But actually, let's go one level deeper. The reason for those shifts, or eras in AI, wasn't just better hardware. It was a fundamental change in the operating logic. To truly grasp the difference between simple automation and true AI, we have to look under the hood at two core ways a system can function: deterministically and probabilistically. This is one of the most important concepts we are covering today. So, if there's one thing you should take away from this entire webinar, I want it to be this concept we're about to cover. It's the fundamental difference between traditional software and modern AI, this split between deterministic and probabilistic systems. So first, let's look at these deterministic systems. As the name implies, it's all about certainty. This is a simple, rule-based system that follows explicit, pre-programmed rules. The calculator is a perfect example. For any given input, the output will always be the same. 2 plus 2 will always, with 100% certainty, equal 4. Now, on the right, we have probabilistic systems, and this is all about likelihood. Instead of following a fixed rule, these systems make a prediction by analyzing vast amounts of training data. And as the graphic is showing, the goal isn't to hit the exact same spot every time, but to get as close as possible to the most probable outcome. That's why the output isn't a single right answer. It's a percentage or a confidence score, like there's an 80% chance of rain. So we have these two fundamental logics, one based on certainty and the other on likelihood. Now, let's see how these map to business terms we use every day. That deterministic, rule-based logic we just defined, in the business world, that is the engine for automation. You can use it for tasks that are repetitive and predictable. This is the Era 1 AI we talked about. Systems that follow explicit instructions, like automatically sending an invoice when a project is marked complete. And that probabilistic, prediction-based logic, that's what we mean when we talk about AI in the modern business world. It's the engine for Eras 2 and 3. You use it for tasks that require judgment, like analyzing customer reviews to predict the top complaint themes about a product. And this brings us to the single most important sentence that summarizes everything we've just discussed. Automation follows rules. AI makes predictions. This is the clear, practical distinction for today's world. Automation is the current term for those traditional rule-based systems, and AI refers to the modern probabilistic systems. Understanding this is the key to thinking strategically about AI. Now that we have this crucial framework, let's apply it to the most advanced expression of probabilistic AI on the market today, generative AI. Our next era is generative AI, and its purpose is to create something that didn't exist before. But we need to be precise about what create means for a machine. An AI doesn't have an imagination like a human. For an AI, creation is the intelligent assembly of something new from existing pieces. And the technology that has truly mastered this creation as assembly for language is the large language model, or an LLM, which we just defined. It's the engine behind the most powerful text-based generative tools today. We are going to focus on text-based generative AI for the rest of this webinar, but this PRISM model can also serve as a foundation for how to think about how other types of generative AI models create. This graphic gives us the perfect metaphor for how to visualize the difference. Imagine our data, or our prompt, is like a single beam of light. Traditional AI, the analytical kind, acts like a lens. It takes that light and focuses it down to a single sharp point. Its job is analysis, to find one specific answer that's already hidden within the data. But generative AI, powered by technologies like LLMs, acts like a prism. This is the key. A prism doesn't invent new colors. The colors are already present in the light. The prism simply unscrambles it and reassembles it to reveal a full spectrum of new combinations. This is exactly what we mean when we say AI creation. So the prism shows us what's happening conceptually. Now let's look at how the machine actually performs this incredible act of reassembly moment by moment. The underlying engine is surprisingly simple to understand. That whole grand process of revealing a spectrum that we just saw with this prism diagram boils down to one simple repetitive task, an idea you're actually already familiar with. What you're seeing here is the predictive text on a smartphone. Based on the first few words of the sentence, the phone is making a simple, probabilistic guess about the next most likely word. This is a tiny prediction. So hold this simple idea in your mind, this engine of next word prediction, because it's the absolute core of how a much larger and more powerful model works. So let's take that simple idea from the smartphone and scale it up. A generative AI powered by an LLM does the exact same thing, just on a more powerful and sophisticated scale. For any given sequence of words, it analyzes all the patterns it has learned and calculates the probability for what the very next word should be. Here, you can see it's weighing the likelihood of several different options before selecting the most probable one to continue the sentence. And this is key. By stringing together thousands or even tens of thousands of these tiny, simple predictions, one after another, it assembles the full complex output. It's not thinking in the human sense, it's predicting over and over and over again at an incredible speed. So we've established that the engine of generative AI is next word prediction. Now, let's look at how we actually interact with it. At a high level, the process is very simple, and maybe some of you are already familiar with it. You start by providing a prompt. This is your instruction, your question, or the context you want the AI to work with. The generative AI model then takes the prompt and, using its prediction engine, generates a brand new output in response. But what's actually happening inside the machine between your prompt and its response? Well, let's break that down on the next slide. Here's a closer look at that process. So first, the model doesn't see your prompt as a complete sentence. It actually breaks it down into smaller pieces called tokens. You can think of tokens as words or even syllables. This process is called tokenization. These tokens are then fed into the core of the AI, its neural network. This is the brain that has been trained on all of those patterns from massive amounts of data. Once the network understands the prompt, it begins the prediction loop we just talked about. Based on the tokens from your prompt, it calculates the most probable next token and adds it to the sequence, then reevaluates and predicts the next one and the next one after that. It repeats this process, token by token, at incredible speed, assembling the words into a full, coherent sentence as the final output. This entire journey, from your prompt to the final word, can happen in a matter of just seconds. So now that we understand this mechanical token by token prediction process, it's absolutely critical that we understand its biggest limitation. Let's be very clear about the core goal of a large language model. As you can see, its primary objective is to generate a plausible sounding sequence of text. It is a master of patterns and probability, but it is not a database of verified facts. The AI has no concept of true or false. It only knows what is probable. This means that if a fabricated or incorrect statement is statistically likely based on the patterns in the AI's training data, the LLM will generate it with complete confidence. This is what we call an AI hallucination. And this is why, despite how powerful these tools are, we have to talk about the non-negotiable role of the human expert in this process. Because these systems are designed for plausibility and not truth, they cannot be left on complete autopilot. This brings us to the most important relationship in the modern workplace, the partnership between the human and the machine. It's not about one replacing the other. It's about connection, collaboration, and some controls. The AI provides speed, scale, and that initial draft. But the human provides context, the critical thinking, and the final verification. One without the other is incomplete and, frankly, risky. So, what does this partnership look like in practice? Well, it comes down to a few key principles. Here are 4 crucial principles to remember when you're working with generative AI. First, remember that outputs are based on probability and not accuracy. Always keep in mind what's happening under the hood. You're getting the most probable answer, but that's not necessarily the most factual one. Second, the golden rule. Always check the outputs before you use them. Fact check, verify. Use these tools as a starting point, but never as a final, unquestioned source of truth. Third, if your organization is implementing these systems, remember, garbage in, garbage out. The quality and accuracy of the training data directly determines the quality of the output. And finally, when you're evaluating AI tools from vendors, ask them about their safety protocols. Ensure they're building their products with human oversight in mind. Responsible AI is a critical part of any purchasing decision. Ultimately, this all comes back to defining AI's proper role. Think of it not as an oracle, but as a brilliant, tireless assistant. Your expertise guides it, your judgment refines its output, and your critical thinking ensures its power is used effectively and responsibly. The goal isn't to replace our thinking, it's to augment and accelerate it. All right, so we have journeyed from the earliest rule-based systems all the way to the AI as an assistant in your workflow. I know that was a dense path we just walked, so please feel free to revisit sections in this video or shoot me an email for any questions you may have. As we wrap up, let me quickly recap the ground that we've covered today. First, we reframed AI's history not as a timeline, but as 3 distinct eras of capability, from simple rules to pattern recognition, and then to content generation. Next, we define that critical split between deterministic automation, which follows rules, and probabilistic AI, which makes predictions. This is your key strategic framework. And finally, we've seen that generative AI works by assembling new content through thousands of tiny predictions, which positions it as a powerful assistant for our work, but not necessarily an oracle of truth. So here's my challenge for all of you this week. I want you to become an AI detective in your own workflow. Identify one process or task that is a bottleneck for you. Then ask yourself this simple diagnostic question. Is this task deterministic and rule-based? Could it be a candidate for AI automation? Or is it probabilistic and pattern-based? Could it be a candidate for AI assistance? This isn't just an academic exercise. It's your first practical step in harnessing this technology. Thank you once again for your time and attention today. Here's how you can get in touch with me or the Aseto team if you have any questions, want to leave us some feedback, or want to hear more about what's next in our webinar education series. If you enjoyed this webinar, please feel free to like the video, subscribe to our channel, and share this with friends or colleagues who may also be interested. Have a great rest of your day. Bye now.